The Daedalus Cube is an amazing creation by Gregory Benedetti. Benedetti is a puzzle designer from France and has produced hundreds of puzzle designs. Most of the ones I've seen are burr-based designs using cubes or voxels as their basic building block. Benedetti has over 100 designs listed on the website puzzlewillbeplayed.com, and anyone can build copies from them. I recently stumbled across the Daedalus Cube design and was intrigued to see if I could make a version using 3D printing technology and some simple hardware. After some successful model builds, I thought it might be nice to share the design with some other puzzle enthusiasts who also enjoy creating puzzle projects. And this is a project, it's not a simple print, and it'll take some time to construct and learn. In fact, in the wooden version of this, a 53-page user manual comes with it to help the user go through the solution. Benedetti submitted the Daedalus Cube to the IPP Puzzle Design Competition way back in 2011. And at this time, there were a small number of models that were created. Typical burr-style puzzles have pieces that simply fit together, but here you can see the intricate tracks and pins that constrain the parts to distinct paths. The object here is to separate the cube into its individual parts and then put it together again. It's up to the solver to move the parts along these paths into positions that allow parts to be removed if you're disassembling or inserted during the reassembly process. This is pretty precise and requires 3/1000ths of an inch of precision if you're building this in wood. Hence, only a limited number were available. And you can see here that they go for between $200 and $400 likely. The last run I've seen was in 2020, and from what I've read, it sold out in about 5 minutes. This is a chance to build this amazing puzzle for your own enjoyment, and I'm going to produce 2 more videos. The first will show you how to build the cube, all the print setups, how to use the pins, how to make sure everything works properly, and then a step-by-step solution video using the model that I've created. Now this is intended for those who really enjoy creating a complex functioning model and want a puzzle design that will take some time to master. Now, as I've mentioned, there was a 53-page user manual that came with this to show how it was built and how to solve it, take it apart, and put it together. So it does take some time to master. So I wasn't sure at first if I could create a functioning model. I used simply publicly available information on the internet, such as YouTube videos and various pictures. I modeled all the parts in Fusion 360, and Fusion's been a dream to use for this type of work. I think the original puzzle used about 25 millimeter voxels or cubes. I used 20 millimeters and I made them fairly thick with 50% infill. I used all PLA, which worked very well. And it's got a nice heft to it. The part that you can see here is 40 millimeters high or long, and the other 2 dimensions would be 20 millimeters. I used M3 socket head screws instead of the pins, and they work really well. You need the socket heads which have 3 millimeters of thickness to the top, so they sort of imitate the pins. I wasn't sure if I could get enough precision, but yes, I'm simply using a 3-year-old Prusa MK3S Plus, and it certainly got the precision to provide accurate and smooth operation. I used 0.2 millimeter layer height. I wasn't sure if that was good enough for the vertical holes that I'd need to create. I could have gone to 0.1 millimeter layer or 0.05 millimeter layer to get more precision on the vertical surfaces, but that would have quadrupled the printing time. Now the nice thing about 3D printing is it also allows some customizations or enhancements, and I'll show you some of those that I've used. For precision on the vertical surfaces, one of the problems of using a discrete layer height is that you get some error on this side. If you only have layers that are 0.2 millimeters in height, you'll get some flattening in here at the bottom and tops of circles. But there's a little design trick that you can use to add a little V to the bottoms or tops. And that means that the flattening area will happen down outside the circle. And this doesn't affect the pin that will go down or inside this cutout. the frame could be printed in one part, but you have a lot of these vertical surfaces and you get certainly much more precise cuts if you can use the top or the bottom surfaces. So I broke this into 3 parts here, and these are glued together with these cutouts. You'll see 2 long screws here, and that just gives some strength. Some parts are embossed. Here you see a happy face here. They aren't available, that's not available on the outside of the cube. It's just to help position the cube when you're assembling it, so you don't need to rely on memory. And I've added a 5mm magnet right here, and you'll see why that can add some usability. The green cube here was my first iteration of the Daedalus Cube, and the blue version is an enhanced or improved version. Now the first 2 parts which come out really are very easy to dislodge, and if you just shake it a little, they'll sort of pop out. In the second or blue cube, I added some magnets so they would have a little force holding them in and wouldn't pop out quite as easily, and you can see that here. So there are 4 magnets, 2 pairs, holding these parts in, and they come out very easily, but you can't simply shake them. So adds a little, I think, a little enhanced usability to the solution. Now, besides the 3D printing filament, you need some hardware, but it's not much and very cheap. For the pins, I use the M3 by 6mm screws. You can use the black. I've used the black in one model, which is just steel. The shiny ones there are stainless steel, and they're very cheap. I think less than $2 for about 50 from AliExpress or Amazon. Now you need the socket head type screws that are 3mm thick that you can see here, so they act as the pins inside the channels. This long screw here is an M3 by 16, and that's used in the 3-part frame. You only need 2 of those, and the head here can be any type. It could be a button type or a countersink type. And you require 2 magnets. Now on AliExpress, if you order 5mm by 2mm, you'll actually get 5mm by 1.7mm, at least in most of the stores that I've purchased from. So the cutouts in my models are about 1.9mm, assuming you're getting this thickness of magnet. Now if you need a different thickness magnet, you can leave a comment on the Printable site, and I'll provide some custom models for just those parts that require the magnets. So the next video will show how to build the Daedalus Cube using 3D printing technology and the hardware. The STL files will be available on my printables.com site. You just need to look for the designer at Crab. That's my username. The design is copyrighted by Gregory Benedetti. Please only use this for your personal use and enjoyment. Don't sell it or violate any copyright rules. I tried to contact Gregory Benedetti by reaching out to several of the puzzle community and wasn't able to get any contact information from him. If he sees this, he can simply contact me through the comments of the video or by messaging me on the Printables website.